Good afternoon, students. We are going to start our class now. Today, we will be starting algebraic identities. Before I start the class, please confirm that all of you are able to hear my voice very clearly, and you are able to view the digital screen properly.
Yes, sir.
Yes, sir.
Oh, okay, great. Thanks. Thanks for the confirmation. So, what is algebraic identities? Algebraic identities is nothing but algebraic equations that are true for all values of the variables occurring in it. Okay. For example, let me give you an example so that it will helpful to understand. Suppose we write an equation something like this: x plus y whole square. As you all know, this is equal to x square plus 2xy plus y square. This is an identity. Why this is an identity? Because it is going to be true for all the values of the variables occurring in it. What are the variables here? X and y. For any value of x and y, it is going to be true. So for example, you apply x equal to 3, y equal to 4, find the value of the left hand side. Whatever you will get the same value in the right hand side, and that is why it is called identity. Whereas equation is different. Suppose if I write something like this, that 2x plus 5y minus 7 is equal to 0. This is an equation. It is not that for any value of x and y, it is going to be true. To solve this one particularly, you need another equation with x and y to find the value of x and y, uniquely. And that is the fundamental difference between the, equation and identity. So in brief, what I can say is that algebraic identity is an algebraic equation that is true for all values of the variables occurring in it. Now what I'm going to do now, I'm going to write few algebraic identities, and I expect each one of you open your notebook, write down this also, and you need to remember all these things. You need to remember so that you can apply all these algebraic identities in the questions which will be followed after that. Okay. In case anyone has any difficulty in any of this one, please do let me know, and we will discuss. I will further explain. Okay. This is the first set of identities. If anyone has any doubt in any of this, please do let me know. I'm just not, unless you ask me a question, I'll not able to understand that why it is so. I hope you understand this thing. A plus b whole square is equal to a square plus 2ab plus b square. A minus b whole square is equal to a square minus 2ab plus b square. Then a plus b whole square plus a minus b whole square. It is just adding up the both the sides in the previous two identities. Then you'll get 2 into a square plus b square. A plus b whole square minus a minus b whole square is equal to 4ab. A square plus b square is equal to a plus b whole square minus 2ab. It's a different way of representation. Then you see that a square plus b square also you can represent it as a minus b whole square plus 2ab. a plus b whole square is equal to a minus b whole square plus 4ab. A minus b whole square is equal to a plus b whole square minus 4ab. Okay, if all are fine, then you can go to the next set of identities. The next set of identities, as you see, dear students, is that a plus 1 by a whole square is equal to a square plus 1 by a square plus 2 when a is not equal to 0. Because if a is equal to 0, then 1 by a is undefined, become undefined. 1 by a become 1 by 0, which is undefined. A minus 1 by a whole square is equal to a square plus 1 by a square minus 2, same condition when a is not equal to 0. A plus b plus c whole square is equal to a square plus b square plus c square plus 2 into ab plus bc plus ca. A plus b minus c whole square is equal to a square plus b square plus c square plus 2 into ab minus bc minus ca. A minus b plus c whole square is equal to a square plus b square plus c square plus 2 into minus ab minus bc minus c. If you remember this thing, that a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca, from there actually you can find the other two. How you know? Because the moment you need to find a plus b minus c whole square, just instead of c, you can write minus c. Instead of c in this identity, you can write minus c. Then what will happen? That a square plus b square plus c square, so plus c square become minus c whole square. Minus c whole square is c square, that is why c square. But bc and ca, that become minus, so that is why it is minus bc minus ca. I hope you got it. If you didn't get it, then please never hesitate to ask me. Similarly, a minus b plus c whole square also it goes in the same manner. A square plus b square plus c square plus 2 into minus ab minus bc plus c. I hope you got it. Now, if I ask you what will be the formula for a minus b minus c whole square, what it? Would you please tell me what it will be? If I ask you what will be the formula for this one? A minus b minus c whole square, what it will be? Could you please do it and let me know what it will be? You can take a couple of minutes. No one?
So it will be a square minus a square plus b square plus c square.
Hmm?
A
Correct.
square. Oh, okay, so along with that minus 2ab plus 2bc minus 2c.
Okay, let's find it out together. Okay, so how we can find it out? So what we can write here is that this is equal to what we can write a minus b plus c. Correct or not? This we can write a minus b plus c whole square. Correct or not? So then what we are going to get? A square minus 2 into a into b plus c plus b plus c whole square, correct or not? So that is equal to a square minus 2ab minus 2ca plus b square plus c square plus 2bc. Exactly, this is what you said, na Kalpita? So that is equal to,
Yes,
yeah,
sir.
a square plus b square plus c square. You can write it different way. You can write it that if you take minus common, if you take minus 2, then AB minus BC plus CA. I hope all of you got it.
Yes, sir.
Okay, great. Now in the same manner, so you can, what about the previous formulas I have done? No? That a plus b plus c whole square, a plus b minus c whole square, all these things you can achieve in the same manner. Now the next set of formula, what we are going to do is something like this, that please go through it. Let me put it here and please go through it, and do let me know if you have any doubt in any of these identities. Okay, I hope all these are clear to you. Okay, the next set of formulas what we are going to discuss is with respect to that cube. So the first thing is that first formula what we are going to discuss is about the a plus b whole cube. That much of detail is not there as long as class 9 is concerned, but I want you to go through all these things because it is going to help you later in a great manner. So that's why it is I strongly recommend that you go through all this. And here is the formula for a plus b whole cube. A plus b whole cube, as you see, dear students, it is a cube plus 3a square b plus 3ab square plus b cube. That we can write also as a cube plus b cube, plus we can take 3ab common and then a plus b. Similarly, a minus b whole cube is equal to a cube minus 3a square b plus 3ab square minus b cube. So if you know the first one, you can find the second one also. Okay, let me tell you, with knowing the first one, how you can derive the second one. As you know that a plus b whole cube is equal to a cube plus 3a square b plus 3a b square plus b cube. Now what we are going to find? We are going to find a minus b whole cube. A minus b whole cube is what? A minus b whole cube is nothing but a plus of minus b whole cube. Correct or not? So as if we can write this is equal to a cube plus 3 into a square into minus b, because we are going to apply this formula, plus 3 into a into minus b whole square plus minus b whole cube. So what we are going to get then? This is equal to a cube minus 3 into a square b plus 3 into a into b square. Why plus 3ab square? Because minus b whole square is nothing but b square, and minus b whole cube is minus b cube. All of you are well understood, no? Any doubt at any moment of time, never hesitate to ask me, as I always say. So this is the way we find the value of a minus b whole cube. That is a cube minus 3a square b plus 3ab square minus b cube. That also we can give in a different form. That we can write is that we can rearrange as a cube minus b cube. Now between minus 3a square b and plus 3ab square, we can take minus 3ab common. If we take minus 3ab common, what we are going to get? We are going to get a minus b. So this is what we got, the second one. Okay, I think I wrote this thing 2 times. I no need to write this thing. So this is already I have written a minus b whole cube. Yeah. Okay. Okay, the next set of formulas, what we are going to learn now is that a cube plus b cube, how we can express in terms of that product of 2 expressions and addition and subtractions of 2 expressions. So please have a look into it. I'm just going to put it here. So what we get, a cube plus b cube, that is equal to a plus b into a square minus ab plus b square. Let me give a cube plus b cube is equal to a plus b into a square minus ab plus b square. That is also equal to a plus b whole cube minus 3ab into a plus b. Okay. I can show you how come a cube plus b cube we are going to get like this. Okay. So let me use a different color and let me explain you. So we are going to establish this formula, that a cube plus b cube, why it is like this. So what we know, dear students, is that we know that a plus b whole cube is equal to what? A cube plus 3a square b plus 3ab square plus b cube. So this implies what? This implies we can write a cube plus b cube plus 3ab 3a square b plus 3ab square is equal to a plus b whole cube. Correct, na? So from here what we can write? We can write is that a cube plus b cube, a cube plus b cube is equal to a plus b whole cube minus 3a square b minus 3ab square. So from there, what we can get, this implies a cube plus b cube is equal to a plus b whole cube minus 3ab into a plus b. Correct, na? This implies a cube plus b cube. Now, between a plus b whole cube and minus 3ab into a plus b, we can take a plus b common. If we take a plus b common, then what we are going to get? We are going to get a plus b whole square minus 3ab. So this implies a cube plus b cube is equal to a plus b into a plus b whole square is what? A square plus 2ab plus b square minus 3ab. So plus 2ab and minus 3ab, that get, we can simplify and we get minus ab. So what we get? A cube plus b cube is equal to a plus b into a square minus ab plus b square. We have established this one, this identity, and that is what we have written it here. By applying the same step, you can establish the formula for a cube minus b cube. So what you do is that if you see that there are two versions, one version is a plus b into a square minus ab plus b square, that we have achieved here, and another version is that a plus b whole cube minus 3ab into a plus b, and that we have achieved in the intermediate step. Correct, no, dear students? So this is also we have achieved. So these are the things you need to, you can also establish these formulas at your end. But what is important, that you need to remember this formula. Remembering all these things are very important to simplify. As I said earlier also, I am not repeating the same statement again and again, but you need to remember these formulas. Yes, it is not possible to remember today, but within a week you should be remembering all these things. And the last one is that, in context to this, is that a cube plus b cube plus c cube minus 3abc. So this is also an important formula. So, and the formula is that something like this, as you see, dear students, here. A cube plus b cube plus c cube minus 3abc, that is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. Okay, that you can achieve, that you can prove also. You can take a plus b plus c whole cube, that you can make a plus b plus c whole cube, and in that way you can prove it. Okay, but this identity, that a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca is extremely important. Is extremely important to to simplify so many problems in future, what we will be seeing. Now, what we'll discuss, so this is, we are almost done with the identities, but what I'm going to discuss, I'm going to discuss little advanced topic today. Okay. The first one is that, that always remember that if you get an expression that x plus a into x plus b, okay, always you can express something like this. This is a very important piece of information, that, sorry, this thing though I just said. Always remember that x plus a into x plus b, x plus a into x plus b always be represented as that x square plus sum of the constant terms. What are the constant terms? A and b. That is the sum of the constant terms into x plus product of the constant terms. One example. One example is that if you can say that, okay, how to express x plus 2 into x plus 3. So the simplified one is that x square plus, what are the constant terms here? 2 and 3. So sum of the constant terms, that is 2 plus 3. 2 plus 3 into x plus product of the constant terms, that is 2 into 3. That is equal to what? That we are going to get x square plus 5x plus 6. So we can express x plus a into x plus b as x square plus sum of the constant term into x plus product of the constant terms. Now the next topic, what I'm going to discuss is that how we can express, a square plus b square plus c square minus ab minus bc minus ca as a sum of squares. Okay. So our next point of discussion is something like that, and I'm going to derive along with you. And as I said, dear students, that you can also open your notebook and do along with me. In case you are not doing, please do it now. So we are going to express that a square plus b square plus c square minus ab minus bc minus ca as a sum of squares. That means what? That a square plus b square plus c square, whatever the term you are seeing here, that entire term, that should be expressed as sum of few quantities. Means sum square plus sum square, like this, sum of squares. That we are going to achieve now. And how we are going to achieve that, I'm going to show you now. So how to do this thing? That a square plus b square plus c square, a square plus b square plus c square minus ab minus bc minus ca, that we can write as, we can multiply it by 1 by 2, and to make thing the same thing, we can multiply the with 2. 1 by 2 into 2 becomes same, so 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. Correct, no, dear students? So that is equal to what? That we can write is that 1 by 2, the 2a square plus 2ab square plus 2c square minus 2ab minus 2bc minus 2ca, we can write like this: a square minus 2ab plus b square plus b square plus minus 2bc plus c square plus c square minus 2ca plus a square. Correct, dear students? All of you agree to me? We can write like this. So that is equal to what? 1 by 2. A square minus 2ab plus b square is a minus b whole square. B square minus 2bc plus c square, that we can write is that b minus c whole square plus c square minus 2ca plus a square, we can write is that c minus a whole square. And that is the, expressing as a sum of the squares. So what we achieve? What we achieve is that something like this, that a square plus b square plus c square minus ab minus bc minus ca is equal to 1 by 2 into a minus b whole square plus b minus c whole square plus c minus a whole square. So this is an important formula that when you need to express the term in the left hand side as a sum of the squares as shown in the right hand side. Now from this formula we are going to derive two important points. The first important point is that if you see if a, b, c be any three real numbers, then we must get a minus b whole square, b minus c whole square, and c minus a whole square as positive real numbers. Correct? So as whatever you see in the right hand side, that is a positive real number. So what we can say is that left hand side is also real number. So for any real number ABC, a square plus b square plus c square minus ab minus bc minus ca is always positive. That is a very important observation. I hope you got it, dear students. You take ABC any real number, then a minus b whole square should be positive, na? A minus b whole square should be positive, b minus c whole square should be positive, c minus a whole square is also positive. So if we add all these positive terms, that is also positive. Now divide this thing by 2, that is also positive. That means whatever we see in the right hand side, that is 1 by 2 into a minus b whole square plus b minus c whole square plus c minus a whole square, that is a positive term. So that means if it is a positive term, then as whatever you see here is an identity, then left hand side, that is a square plus b square plus c square minus ab minus bc minus c, that should also be positive. So that is the first important observation. What we can conclude is that for any real number, for three any three real numbers a, b, and c, a square plus b square plus c square minus ab minus bc minus ca is always positive, is always, we can write greater than equal to 0. Now the point is that as you say that as you see that a square plus b square plus c square minus ab minus bc minus ca is greater than equal to 0, then you say, why you write 0? Greater than 0 is I understood, but why it can be equal to 0? For some condition it can be equal to 0. Could you please tell me what is that condition for which that a square plus b square plus c square minus ab minus bc minus ca will be 0? Can anyone please say? Under what condition? Is the question clear to you, Manishika? Is the question clear?
Yes, sir.
Okay. The question here is that under what condition that a square plus b square plus c square minus ab minus bc minus ca is going to be 0? Trivali, could you please answer this one? Kalpita?
So if the value of ABC is 1,
let's say if we see the value of ABC is equal to 1, then what you are going to get? You are telling the value of A is equal to 1, B equal to 1, C
Yes,
equal to 1.
yes, sir. Means
Okay,
individually, A is 1, B is 1, C is 1.
okay, okay, appreciate, that is correct. But what about if I take A equal to 2, B equal to 2, C equal to 2? Then it's going to be 0 or not?
Yes, sir.
Correct, no?
Yes,
So,
sir.
so to make your statement, what you say to a generic one, yes, if A is equal to B is equal to C, then the value of the expression is going to be 0. Correct, no? Got it? So from here is that what we can conclude is that A square plus B square plus C square minus AB minus BC minus CA, that will be equal to 0 if you can
So
write
then if it's equal to 0, instead of like putting different variables, you can put A or B or C also, right?
correct. A is equal to B equal to C. That means if you replace B by A and C by A, you will get it 0. Or to make not to make have any confusion, let's apply one thing: A equal to B equal to C equal to K. Okay, let's see what is the value we are going to get. If we take from this one, let me use a different color. So from here, what I'm saying is that we are going to apply the value of A is equal to B is equal to C is equal to K. Then what we are going to get? We are going to get A square plus B square plus C square minus AB minus BC minus CA is equal to, let's apply here in the right hand side, half of A minus B whole square, right? A minus B means what? K minus K whole square plus B minus C whole square, that is equal to K minus K whole square plus C minus A whole square, that is equal to K minus K whole square. Correct or not? All of you got it? Srivali, absolutely clear to understand?
Yes, sir.
Okay, so A plus A square plus B square plus C square minus AB minus BC minus CA is equal to 0 when A is equal to B is equal to C. Manishika, absolutely clear?
Yes, sir.
Okay, so that is why I wrote this word called IFF, if and only if. We had a brief discussion in the last class, right? So the thing is that always remember that one more conclusion we are drawing from here is that three real numbers, if you take three real numbers x, y, z, okay, is generally the square of these three real numbers is always equal to, greater than equal to 0 generally for any three real numbers. So what you can conclude, if I use a different color and explain, for any real number for three real numbers x, y, and z, what we can write is that square, obviously square is positive, right? That's what we know. Whether x and y and z are positive or negative, that should be always greater than 0. But we can write greater than equal to 0 also. And we can write equality holds true. Equality holds true when x is equal to y is equal to z is equal to 0. Equality holds true when x equal to y equal to z is equal to 0. Clear? Absolutely clear. Great. Now, dear students, what we are going to do, we are going to solve some problem together. So open your notebook. I'm going to give you one by one questions and we'll solve together. I'll give you in a couple of minutes so that you can start solving it, and do let me know your answer. You can, I'll appreciate uh, if you can send me your solution also over WhatsApp. If WhatsApp is access, you can use our email also. You can send me in real time over email. Real time means immediately whatever you can send, either WhatsApp or email or Google Hangouts, whatever. So that purpose is that immediately I can, at the same real time, I can bring that your solution to the a digital board, and I can discuss if there is any scope of improvement. Is the question clear? Able to view the questions, dear students?
Yes, sir.
Okay, go ahead. Is it done? The first one?
Yes, sir.
Yes, sir.
Okay. What is the value we got?
7a plus 5b whole square.
B into 7a plus 5.
Correct. 7a plus 5b whole square. Correct. Good. Appreciate. Second one is done?
Yes, sir.
Okay.
Yes, sir.
Second one, what you got?
5x
5x by 2
by 2 plus y by 3 into 5x by 2 minus 5 by y by 3.
Correct. So, good. Appreciate. So, you get 5x by 2 plus y by 3 into 5x by 2 minus y by 3. So, now what I'm going to say is that you can express this in expanded form, and whoever is done, please do let me know that you are done with it so that I can ask this question.
So 25x, so the second one,
Yep.
25x squared by 4 minus 5xy by 3 plus y squared by 9. Is it?
Now you need to factorize. So this one, if you factorize, so what we're going to get it is that this we can write is that 5x by 2 whole square, right? correct? Minus y by 3 whole square, correct or not? Clear or not clear? Should
So it will be minus y by 3 whole square.
no minus
Just
not
that part. Okay. Yes, I got it.
So thanks for asking question. Asking question is very good. Plus y by 3. You should not have any doubt, at the end of the session. 5x by 2 minus y by 3. Correct, no? Any doubt here? Clear, no? Absolutely. Okay. So that was question number 1. Now here question number 2. Please write 3a plus 4b plus 5c whole square in expanded form.
Sir, can I tell the answer?
Yes, absolutely. If you're done, you are absolutely.
Sir, is it like 16b square plus 25c square plus plus 9a square plus 2 into 12ab plus 20bc plus 15ac?
Oh, no. You get 15AC. 15AC is not correct. Look into it. What is the formula? Tell me the formula. What formula you are using?
A plus b plus c whole square.
What is that? A plus b plus c whole square.
A square plus b square plus c square plus 2 into ab plus bc plus ca.
So then 2 into AB, na? 2AB, 2CA. So finally, final answer, what you are getting? Tell me once more, please.
So I should remove the brackets and like
Yeah, yeah,
multiply everything by 2. Okay, fine, I'll do that.
yeah, yeah. Next, who got it?
So is it 9a square plus 16b square plus 25c square plus 24ab plus 40bc plus 30ca?
Fantastic. Appreciate. Exactly the correct answer. Look into the solution. I hope all of you got it. Next question I'm going to give you, dear students. Third question, dear students.
So I have done it.
Okay, great. Tell me.
So 16a square plus 4b square plus 9c square minus 16ab plus 12bc minus 24ca.
Fantastic. Appreciate. All of you got it?
Yes, sir.
Okay, great. Manishika, you got it?
Yes, sir.
Okay, great. And just have a quick look into it. So the next question, what I'm going to give you is that you need to factorize. So factorize means what, dear students? You need to express this thing, that expression, as a product of few expressions. Got it? That 4x square plus y square plus z square minus 4xy minus 2yz plus 4zx. That you need to express as product of expressions.
So will it be like 2x minus y plus z into 2x minus y plus z?
Perfect. Appreciate. Very good. Great one. So, dear students, so how we are doing this one? Is that 4x square plus y square plus z square minus 4xy minus 2yz plus 4xz. What we can write is that we can write is equal to 2x whole square, okay, plus minus y whole square, okay, and plus z square. Then what we are going to get, plus 2 into 2x into minus y. That is why we can write minus 4xy. Then plus 2 into minus y into z. That we can write is as minus 2yz plus 2 into 2x into z. That we can write is at 4zx. So now if you recall the formula for a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca, and we can write this is equal to what? We can write, just a minute, we can write that is equal to 2x minus y plus z whole square, that is equal to 2x minus y plus z into 2x minus y plus z. Correct, no, dear students? All of you got it, I hope. Please do the next one. Question number 4. Oh, sorry, it should be question number 5.
The answer will be 20, the first one, answer will be 27 a cube plus 108 a square b plus 144 ab square plus 54 b cube.
54.
64,
64.
64. Sorry.
Correct. Correct. Yeah. Correct. Correct. Exactly.
So your screen is not shown again. Can't see your screen, the board.
Oh, is it all of it? Is it true for all of you?
So I can see.
Okay. So I'm not sure what happened. Manishika, you are not able to view it?
No, sir.
Okay. Let me stop presenting and let me present once more.
Sir, my network went down for a few minutes. What had happened while I was gone?
Okay. No problem. It happens sometimes. So please confirm that you are able to view the screen.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, great. So first answer is absolutely correct. As you said correctly, the 3a plus 4b whole cube. That is correct. So could you please tell me the next one? So this is for the first one. This is for the first one. Could you please tell me for the second one?
25 p cube minus 9 q cube minus 45 p q into 5p minus 3q.
I've got 125 p cube minus 225
Oh
p
shit,
square
yeah, yeah.
cube plus 135 p q square minus 27 q cube.
Correct. This is precisely the correct answer, because when the question is in that you need to express in the expanded form, it is not to write any, you need to write like this. Got it, Manisika? Hello?
Yes, sir. Yes, sir.
Yeah. So this is the solution for this one. Okay, the next question, what I'm going to give you, dear students, is that you are not supposed to use any calculator. Please promise that you will not use calculator either in your computer calculator or in your smartphone calculator or normal calculator. Okay, without using calculator or without evaluation, you need to find the values of these following two identities. Following two, with the help of suitable identities, you need to find the value of the following expressions. Is the question clear?
Yes, sir.
Okay.
Yes, sir.
Okay, great. Go ahead.
Sir, is the answer 100216?
For the value of 104 power 3?
Yeah.
Not really.
Okay.
Sir, I have got
I got 1124864.
4864.
One by one, please.
Yeah,
Ah,
for the first
correct.
one. Sir, for the
Yeah,
first
for
one.
the
Yeah.
first one, it is 1124864. So
Okay.
what is the methodology we are following? We are following that 104 whole cube is equal to 100 plus 4 whole cube. Correct, no? A plus B whole cube. Just a minute, let me show you. Correct? Correct, no? Now, after that, what you need to do? After that, you need to just compute all these values. Correct, no? Got it? Okay, for the second one, what is the answer you got, dear students?
1 second, sir.
Yeah, go ahead. No problem. Take your time. What happened? Any doubt? Sure. So how we are
Sir, I got it.
Sir, I got
one,
99700.
one by one. I'll appreciate if one by one if you say. Yeah, Srivali, go ahead.
997002999.
Yeah, others, your answer is absolutely correct. Others got the same thing.
Yes, sir, I have also got the same thing.
Okay, Manishika.
Yes, sir.
Okay, great. Just can I have a look into it? Okay, this is a solution. So the next question, what I'm going to give you is to factorize. Okay. So the question will be available to you in another few seconds. Is the question clear to you?
Yes, sir.
Yep, go ahead.
So the answer is 2x plus 3y whole cube.
Appreciate. It is 2x plus 3y whole cube.
Yes, sir. I got the same answer.
Great. Appreciate. So next question to give you factorization. Please have a look into it.
Sir, I think I got it.
You got it? Great. Please do let me know your answer.
Uh, 2x plus y plus 3z into 4x squared plus y squared plus 9z squared minus 2xy minus 3yz minus 6zx.
Fantastic. Appreciate. All of you got it.
No, sir, I didn't get it.
Okay, let me help you to understand. And thanks for asking this thing. Absolutely not. See, with practice, we'll come to this level of perfection. No issue. So
Yes.
what we are doing is that here, if you see that 8x cube plus y cube plus 27z cube, the moment you see this thing, it looks like that 2x, y, and 3z whole cube. These numbers played a big role here. So this is the solution. But whenever you see 8x cube, y cube, 27z cube, okay, like that, then your mind should go that can I make it as a complete cube of something? For example, the moment you get 8x cube, so you can think of, oh, can I write it that 2 of x complete whole cube? Then you write 27z cube. Then it is equal to, it is 3z whole cube, right? Similarly, if you get 64t cube in future, so 4t whole cube like this should be your thought process. Okay, and I hope rest of the things you are able to get it.
Yes, sir, I understood that.
Okay, great. Okay, next question I'm going to give you, dear students. Is the question clear?
Sir, is it 12?
Correct, you are. Appreciate. Good. All of you got it or not?
Sir, I didn't get how to do it.
Okay. So what is given here, dear students, is that it is given that the value of 1 by a plus 1 by b plus 1 by c is equal to 3 by 2. 1 by a plus 1 by b plus 1 by c is equal to 3 by 2. Then from here what you are going to get the LCM in the denominator is ABC. In the numerator what you will get? BC plus CA plus AB. Any doubt here, dear students? That is equal to 3 by 2, correct or not? Any doubt here? Okay. If there is no doubt, so AB plus BC plus CA is equal to 3 by 2 into ABC. What is ABC? ABC is given as 8. So we get the value of AB plus BC plus CA is equal to 12. Correct?
Okay, sir, got it. Thank you.
Oh, okay, great.
Sir, I didn't get the answer. Like I got it in like a different way.
Okay. Okay. What you did? You can let me know.
So like AB plus BC plus AC. So like from ABC is equal to 8, we can get to know that AB is equal to 8 by C. So like that you'll get 8 by C plus 8 by A plus 8 by B. And in this it's showing A plus 1 by A plus 1 by B plus 1 by C is equal to
Okay.
3 by 2.
Okay. That also you can do. No? You also get value from there. So you are telling that you take this one and you write that AB is equal to 8 by C. Correct? No?
Yeah.
Plus 8 by A plus 8 by B. Correct?
Yeah.
So that is equal to 8 into 1 by C plus 1 by A plus 1 by B. Correct? And this value is already given as 3 by 2. No? So 8 into 3 by 2. Correct? 12. Same value we got. No? Is it clear?
Yes, sir.
Yes, sir.
Okay. So what I will suggest to dear students is that you need to complete all the exercises. All the exercises you need to complete, all the DPPs. What I'm saying is that all the DPPs, what about the DPPs left? Let me share a different screen with you. And you need to complete those DPPs by our next class. And also in the next class we'll start a new topic. I'm just going to share a different screen with you. Please confirm that you are able to view it. Okay.
Yes, sir.
Then
Yes, sir.
great. Then you log in with your. Once you log in, then what you go to the right, online examination. And then here you write polynomials. So we see that total 5 are there. Please make sure that all these 5 are done. Once it is done, then what you can do, once you are done with all these 5 polynomial DPPs, then you can come to the right practice test, type here polynomial, and then start appearing the practice tests. So these are the little challenging questions, but you will appreciate in answering these questions. Okay, please start
Oh,
answering.
it
Yeah,
says chart 10 on the top.
I'm sorry.
It says
Oh, I'm so sorry, so sorry. I'm so sorry. It should be 9. Yep. Ah, yes. So here you'll get little more. Total 11 DPPs, correct? No. So please make sure before we start our next class on Tuesday.
So the
Okay.
screen has paused. I can't see the next screen. It
Okay.
has paused somehow. The voice is also getting disrupted.
Okay. Please confirm that you are able to view it now.
Yes, sir.
Okay. So what I'm saying is that if you say, there are the total 11 DPPs, you need to complete these 11 DPPs before we start our class in Tuesday. And can we start our class in Tuesday at 4 o'clock, dear students? 4 to 5:30, can we do?
Okay, so I don't have.
Possible, all of you? Manishika?
Yes, sir.
Okay.
yes, sir.
4 to 5:30 we'll do from next Tuesday
Okay.
onwards. And once you are done with all these, 11 DPPs in the polynomials, then you come to the right practice test here. Just type here polynomials. You'll start getting, questions. Good. These are the good questions. Okay, these are the questions, are challenging questions. It will help you to think in a, more, challenging questions. You need to think differently, little. Okay, and answer this thing. So with this, I would like to conclude the class for today, and our next class is Tuesday at 4 o'clock. Thank you very much. All right.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.